Hello, my name is David Scotto, and today I'll be informing you on my interim report for the climate change prediction project for the nonprofit organization ClimateWins. So there were two reasons why I was tasked to do this project. The first one was to leverage machine learning to predict the consequences of climate change for the organization, and the second one was to support evidence-based climate action that identifies the best predictive models and that communicates results clearly and directly, informing ClimateWins strategy for maximum real-world impact. The data that I use for this project so far comes from weather observations from 18 weather stations across Europe. It was collected by the European Climate Assessment and Dataset Project. It includes daily observations from 1960 through 2022, and it also includes precipitation, humidity, temperature, and other measures. So there are three potential biases from the data source that we need to be aware of. The first one is a temporal bias. For instance, the data collected in the 1960s could suffer from outdated and potentially unreliable tools and methods. The second one is historical bias, meaning that the large volume of historical data may overshadow rapid climate changes occurring in recent years, which can lead to inaccurate predictions from current and future conditions. And the third one is selection bias. For instance, the data might overrepresent more developed regions of Europe due to the collection of the data, and which potentially excludes or underrepresents less developed areas outside of Europe. So there are three main hypotheses that I had when I first started this project. The first one was that machine learning algorithms will be able to accurately predict future weather conditions. The second one was that prediction accuracy will vary based on geographic location and different climate conditions within regions. And the third one was that machine learning will be an important tool to identify the signs of climate change. Now, in order to corroborate these hypotheses, there were many methods that were implemented. The first method was a simple gradient descent data optimization. The reason why this was the first thing that I did was to see if the data behaved on a linear fashion. Because if it did, we could create a line of best fit, which is the point of the data optimization, which would give us a very good prediction how weather has changed and will change in the future. The way that data optimization through gradient descent works is that we adjust parameters to minimize a loss function, which we can see here on the right side of this graph. This makes the model more accurate by reducing this loss through iterative updates to its parameters, specifically the slope of the line of best fit that we're trying to make and the intercept, which is theta 0 and theta 1 for the slope, respectively. And these adjustments, and we use these adjustments to converge on optimal parameters, which we can see here. This is where the slope converges, and this is where the intercept converges, which hopefully will lead to the loss to get closer to zero. However, I found that this is not as useful as a standalone method, since the data we are looking at is not linear, which we can see, for instance, for the weather predictions. Here we see for Madrid in 2017, the data is not linear, meaning that once we create the line of best fit through the closest slope and the closest intercept, that we can predict, the loss is still not close to zero. It's actually closer to 0.58, which is not good enough. So because of that, because gradient descent through data optimization was not good enough, I performed three machine learning methods in order to see which one was best in predicting weather conditions for our data set. So the first machine learning method that I conducted was the k-nearest neighbor method, or the KNN method, which I will call it from now on. In this method, we make predictions by calculating the distance between new data points and all other data points in the training set. Also, nearby data points are grouped based on the number of neighbors in each group. Here, KNN was used to predict pleasant weather days in 15 of the European weather stations. Pleasant weather days were used as a proxy for climate change, in a sense that if we see that in a part of the world or in a city that mostly had pleasant days, but then slowly had less and less pleasant days, then that could be a sign of global warming. But that is something for later. Here we only want to see if the method can predict whether a specific day of the year, or a specific year, or a specific city will have a number of pleasant days or not pleasant weather days. And using a K-range value of 3, the model was able to predict pleasant weather days with an average accuracy rate of 88% for all the cities that were used in this method. The second machine learning method that was used was the decision tree method. Here, a decision tree makes predictions by answering a series of questions about the features of the data. The tree consists of nodes and branches, which we can see here. We see the branches, and these are the nodes, uh, which new data points follow the flow of the tree based on its best fit. And here the model performed with both training data and test data with an accuracy of 47%, which is much lower than the K&N method. And the third supervised machine learning method that I conducted was the artificial neural network algorithm. This algorithm makes predictions by processing data through a set of layers. Specifically, we use the input layers receive the data, and the inputs are weighted based on their connection to hidden layers. Then hidden layers apply functions to the weighted data and send the results to output layers. Specifically, I conducted several tests, with each test adjusting the hidden layers, the node sizes, the iterations, and the tolerance. However, after conducting all of these steps, the maximum testing data accuracy was 51% only. So what are the limitations of these three supervised machine learning models that I conducted? Well, for the K&N method, uh, for a specific city, which was Sundvik, we saw a 100% accuracy rate. But however, this indicates overfitting. Uh, Specifically, since all training data for this city was not pleasant, the model will always 100% predict that the weather is not pleasant, right? However, this is a problem because the model is failing to learn any real pattern or distinction, meaning that it might not be able to predict how or what specific characteristics temperature should have for it to be not pleasant or pleasant. Um, the limitations of the decision tree method was that it's very complex. It has too many branches, as you saw earlier, and this can lead to a model being too difficult to interpret. And for the third model, here the ANN, the training data accuracy consistently outperformed testing data accuracy. Now, this can change depending on how we tweak the the algorithm. However, overall, the testing data was not as good enough as the training data, which is a problem because if the testing data is not uh, as good as the training data, that means that in essence the model is just learning the training data and not actually predicting anything. So keeping this in mind, which model is better? Well, based on the code that I wrote, based on the methods that I performed, and based on the overall accuracy of these models, I believe that the KNN algorithm is likely the best algorithm for predicting future weather. However, the ANN algorithm can also likely be adjusted to perform at higher levels than currently seen in testing. So let's recap everything we've looked at so far. First, what was the hypothesis? The hypothesis was the machine learning algorithms will be able to accurately predict future weather conditions. The second hypothesis was that prediction accuracy will vary based on geographic location and various climate conditions within the region. And the third hypothesis was the machine learning can identify signs of climate change and its adverse effects. The methods that I used were optimization with gradient descent and supervised machine learning with KNN, decision tree, and ANN algorithms. So based on this, what are the next steps? Well, first, we should incorporate unsupervised machine learning algorithms. Maybe we can see different trends or higher overall accuracy rate that we didn't see with supervised machine learning algorithms. The second step should be to diversify data points to include audio variables for analysis And the third next step should be to continue testing adjustments to increase the model accuracy. So thank you so much for your time. If you have any questions, please don't hesitate to let me know. You can contact me through my email. So that should be it for now. Thank you, and stay tuned for my final report.